So essentially what we're trying to do is build a secure cloud computing platform. And what we really do is we can model our model of computation revolves around the finite state machine. And so a client, which is a computationally weak entity, like wants to offload this computation to a server. So it can essentially encrypt the function it wants to apply and encrypt the data streams, and it forwards them to the server, which the server then applies to the data and returns with a response that's unforgeable. Essentially, it is impossible for someone to try and pretend as if they executed the computation. So here's like a general overview of the protocol, where the client forwards the encrypted function and then forwards any number of data streams, where the server then applies it and returns with the response. And this has many applications to one particular one is regex. Regular expressions can be implemented in state machines, and a lot of spam filtering and malware detection is a lot of times really complex regular expressions. So by doing this, you can offboard basically the decision of whether or not a program is malicious or not. And one of the ways we'll be doing this, or using this in practice, is our first application to software-defined networks. In this model, you have a bunch of routers in the field, and each of their routing decisions is independently controlled by the controller. So in this model, the communication between the node and the server is encrypted using the secure cloud computation platform. So if a packet enters that could be malicious, the node forwards it to the server and says, "Hey, is this packet suspicious?" If this were entirely unencrypted, someone could respond and say, "No, it's not," and then the packet's now in the network and can get on the other nodes. But in this model, the server doesn't know what function it's computing or the data that was passed, so it would be impossible for someone to just say yes or no in response.